Today, many Americans get their cardiovascular workout on an arc trainer. These gym staples use an arc-like swinging motion to eliminate the jarring impact of ordinary jogging.
This place is gigantic. How can it take this much space to make an arc trainer?
Well, we're very vertically integrated here. So we have 8 acres under one roof that we do a lot of the processing, all internal.
Like, what is this area of the factory?
Well, this is where it all starts. Steel trucks will back into that steel bay and will be unloaded with an overhead crane that has a capacity to lift 20,000 pounds.
The first step in building an arc trainer involves cutting out many of the precision steel parts of its frame from these sheets. For that, Cybex relies on this 2,500-watt industrial laser. These flat pieces will be used as brackets to support and reinforce components of the frame.
These are pretty complicated shapes. How does it know how to cut it?
We have computer software that nests the shapes into the best possible configuration to make most use of this 4x8 sheet of steel. The program is then transferred wireless to the machine, and the laser will begin cutting.
It takes just 2 seconds for the laser to heat the metal from around 70 to 2,500 degrees. But this is only one of 4 different lasers at the plant. This tube laser slices out the larger sections of steel tubing that make up the arc trainer's frame. To get these steel tubes into the signature curve shape needed for the frame, Cybex employs this: the roll form. First, the worker loads a tube into position between the 2 front rolls. Then the front rolls feed the tube past the rear roll, which slowly pivots up 2 to 4 inches and applies pressure to give the tube its desired curve. Bending one of these steel tubes takes about 10 tons of pressure. Another set of steel tubes will form the arc trainer's leg bars. To make sure they'll fit snugly onto the frame, workers need to shape the ends of the tubes in this machine, a computer-controlled drill press. A worker secures the tubes with hydraulic clamps and closes the doors to contain any flying debris. Then the drill begins to carve out its precise pre-programmed patterns. Wondering what all that blue fluid is? This drill runs so fast, 1,200 RPMs to be exact. It uses the fluid as a coolant and a lubricant to reduce wear and tear on the drill. Once all the steel parts of the frame have been trimmed and shaped to perfection, it's time to put them together. And it's not a simple task. It takes 84 separate welds to hold all the pieces of the frame together. So Cybex uses a robotic welder.
How does the robot find out what it's going to weld? Like a person would just look at it. How does the robot know?
Well, the robot is actually taught how to weld by the actual welder himself.
So the person's just walking the robot through the path that it wants welded?
That is correct. Once that's been established, then there's a program created, and it's very consistent time after time.
How consistent? These robots are accurate within 5/1000ths of an inch on every weld. At the rate of 50 frames per day, that's over 4,000 perfect welds.
Now we have a finished arc trainer frame.
So this is the whole thing?
This sturdy frame will support all the working parts of the arc trainer, like the foot plates or pedals, the braking system, which determines the degree of resistance and therefore the difficulty of the workout, the console, which controls and customizes the workout, and the arm handles, which help the exerciser maintain proper posture. But before we can attach the rest of the parts, this rough steel frame needs to be polished and protected. And that happens here at the blast machine. This process is like sandblasting, but instead of using sand, it uses tiny steel balls called shot. The flying steel shot is so dangerous, it must be contained in this capsule.
And we're actually firing about 7,000 pounds a minute of steel media at the product as it goes through the blast booth.
So you've got like 8 guns that are around it just shooting. It's like a big dishwasher or something, except it uses steel instead of water.
It's like a very violent dishwasher.
The frame comes out of the shot blast into this sealed room where workers must vacuum off any remaining excess shot. They must wear these protective full body suits to prevent any microscopic dust particles from getting into their lungs.
Wow, this looks awesome.
Yeah, you can see the quality of the product and the quality of the surface after the shot blasting process.
It kind of roughened this up. It got rid of all the little marks, and it got rid of all that grease and stuff you were talking about.
That's right. This is a real high-quality surface.
To protect this pristine surface, the frame gets a quick rinse with water and then a spray of iron phosphate. Iron phosphate forms a coating on the metal that keeps out moisture and bonds with the paint. Now the frames are ready for their final touch, a coat of paint. But for this job, no ordinary paint will do. Cybex paints its arc trainer frames with powder.
Why are you using powder instead of liquid paint that we'd see in a can of spray paint?
Well, there's several advantages for us. First of all, powder paint is better for the environment. We're not dealing with solvents or the emissions. Secondly, it is easy to work with. Third, it gives a great finish to our product. And fourth, it's more cost-effective than standard wet paints.
Now, if I were to touch one of these frames, it's like talcum powder. It would just come right back off. It's being held on by the charge. It's when it goes into the oven that it actually gets melted and bonded and turned into what we think of as paint.
Once the paint cures onto the frame, it's time to attach the working parts of the arc trainer. Now that the arc trainer frame is assembled and painted, workers can attach all the working parts. First, the heart of the operation, the braking system.
Is this a motor here that's driving it?
It's an eddy current brake.
Oh, okay, the opposite of a motor.
Correct.
Okay.
The eddy current brake supplies the resistance that you feel when you use the arc trainer. But instead of using friction like traditional disc brakes, an eddy current brake uses opposing magnetic forces. The 4 coils inside the brake generate a powerful electromagnetic field. When the flywheel passes through the field, currents, like eddies in a stream, flow through the metal of the flywheel. This creates an opposing magnetic field, which resists rotation and slows down the flywheel. The stronger the current, the more resistance supplied by the brake, and the tougher the workout.
So, I'm actually powering this thing, and it's trying to slow me down.
That's correct.
With the braking system installed, it's time to attach the rest of the arc trainer's parts, including the handles, the legs, the pedals, and the computer that monitors the braking system, heart rate, and calories burned. Next, a worker gives each machine its own workout to test the computer and all of the working parts. And finally, it's time for Marshall to give it a try.
Here it is, the Cybex arc trainer. And I'm gonna just set it to manual mode and tell it, you know, you can set the resistance between 0 and 100, so I'll give it 50.
and in about 10 seconds, I'm gonna be out of breath. I started off on the lowest possible setting. You just let it crank up to 100. I can do that for about 15 seconds, so I set that back down to a much more comfortable setting. And it is smooth sailing.